Alright, let's finish this quiz. G prime of 10. Now, again, I've said that many times. You're not, oh, let's circle that, okay? You're not gonna be looking at this to get G prime of 10. Do not look at the output of a function at a point to say anything about its derivative, right? It's got nothing to do with it. So, how do you find G prime of 10? Well, you need G prime of x, okay? G prime of x. So, G prime of x, well, let's derive the expression for G of x. Now, the expression for G of x, again, is f of x, f of negative 4 plus sum from, let me see, I got this right. Sum from negative 4 to 10 to x, of f of t dt. Okay, all right, so you're going to derive that. It's going to be pretty straightforward. F of negative 4 plus the derivative of this piece right there, sum from negative 4 to x of f of t dt. Okay, well, what's the derivative of an output that is, this is a value, this is a real number, okay? So the derivative is a constant, it's 0. I'm sorry, this is a constant, therefore the derivative is 0. And this is an application of the fundamental theorem of calculus, right? So this is just f. Oh, why is it not writing? Come on, oh, right. This is just f of x, okay? That's it. So what do we have? We have that G prime of x is just f of x. So, well, what is G prime of 10? G prime of 10 is going to be f of 10. And what is f of 10? Let's look at the graph. The output at 10 is 0. It's right here. The output at 10 is 0. So it is 0. Okay. All right. Good. Okay, what's going on here? Right. Tricky. Okay, all right. Next question. G second at 10. Same deal, right? You need to figure out what G second of x is. Well, G second is a derivative of G prime. G prime is f of x, so it's a derivative of this is derivative right here of f of x, which is f prime of x. Okay. So G second of 10 is going to be f prime at 10. Now what is this? This is, I don't know, I don't have an expression for f of x, therefore it's gonna have to be a geometric finding here, right? This is a slope of tangent line of f, right, of the graph of f at 10. We also call that the slope of the graph, right, at 10. Okay, so let's look at 10. Let's see what kind of tangent line we have at 10. Well, that's going to be pretty straightforward, right? This is 10. The tangent line at 10, this is a line. Okay, so the tangent line is a line itself. Therefore, the slope of the tangent line is going to be the slope of the line. And to find the slope of the line, I hope this is not a secret to anybody. Everybody can do that. You go down 1 and you move up 2, so it's negative 1/2. Okay, so the slope is negative 1/2. Okay, so G second at 10 is negative 1/2. All right, last question. What do you call the point x equals 10 in reference to the function g? Justify your answer. Well, let's look at the last two answer. G prime of 10 is equal to 0, right? Do you remember what we call that? If G prime of 10 is equal to 0, then actually it's not an if, it is equal to 0. So x equals 10 is a critical point. Okay, is that it? Is that all? Well, actually no, because G second of 10 is negative 1/2. G second of 10, G second of 10, actually I don't care about the value, what I care is that it's negative, right? Is negative So if you put these two things together by the second derivative test, x equals 10 is a local max. Let's justify that very quickly as a reminder, okay? By the second derivative test. See what's going on with CPs quickly. Check it out. Let's get its CP right here. So you can have a CP of a function like that, or like that. Okay, the first derivative is equal to 0. Right here, the first derivative is going to be 0. Right here, the first derivative is going to be 0. And right here, the first derivative will be 0. What's going on about the second derivative? Okay, what's going on about the second derivative? So at this point right here, this is not a pretty color. Oh, everything went. Okay, here we go. Okay, so let me take a blue like that, and I want a thin. I don't know how to use that really. How do I get a thin line blue? Well, that ain't thin. That's not gonna be the blue I want. Okay, whatever. Okay, let's call it A. So we have, and this is gonna be the graph of f. Okay, this is f, and f. So we do have that f prime of A is equal to 0. That's for sure in 3 cases. Okay, in the 3 cases, f prime of A is equal to 0. Now what's going on right here for f second of A in this case? F second of A indicates the concavity of the graph at A right here, and right here anyway, we can see that the graph doesn't change concavity, it's all negative, right? So f second of A is negative, and we do have a local max. What's going on right here? The graph doesn't change concavity. I should use, right, everything went. Okay. There we go. The graph doesn't change concavity, right? It's all, the concavity is turned up, so the concavity is all positive. F second of A is positive. What do we have? We have a local mean. That's the second derivative test, okay? What's going on right here? Well, let's check out the concavity. Here the concavity is positive. Here I'm sorry, I meant negative. Here the concavity is positive, okay? Concavity positive, concavity negative. Therefore, what's the concavity at A right there? Well, you see that at A, it's when the concavity changes from negative to positive, okay? Negative, 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 and positive. So at A, it's neither negative nor positive. It's going to be 0, okay? And right here, you don't have neither a local max nor a local mean. Okay, I hope this reminder is clear. We've studied that in many cases. Okay, this is about the second derivative test. So the test right here would be inconclusive. You have a saddle point. You have a saddle point. Okay. Okay, done. I hope everything was clear. View those 3 videos as much as you need to. Oh, look at that. This is actually your right. View those 3 videos as much as you need to. And that's it. All right. Thank you.